Okay, so here we have a chapter 3. What is learning in Lstm? Learning means Lstm sees input many times. It slowly adjusts its weight so that next time it makes fewer mistakes. Okay, so learning means Lstm sees input many times. It slowly adjusts its weight so that next time it makes fewer mistakes. Think like Lstm is a child. Okay, Lstm is a child, kind of a child. Every time the child makes a mistake and then a teacher corrects it. Next time the child does better. This correction process is called back propagation. We have already know. And what is back propagation through time? BB BPTT means back propagation through time. Lstm reads sequence word by word. If it makes a mistake at the end, it goes back and fixes all the steps. This full sequence correction is called BPT. We have already studied in deep learning that how they calculate loss when they complete their you know forward propagation and then backward propagation. So what are LSTM weights? Each gate has weight matrix W bias and learning adjusting these weights. LSTM training loop. Simple English here we have. Give input, LSTM predict, check wrong or right, calculate error, error, calculate error, error goes backward, waits update, repeat. LSTM training code here we have PyTorch. Then let's see import torque and as an class nn dot module has a lots of power. Then define itself input size, hidden size, super dot. Here we are just taking all the powers using super method. Then self.lstm and then lstm input size hidden size linear. We are taking hidden size 1, then one output depth forward. This is a thinking function. And then h minus self lstm final in final model. Now lstm input size and then hidden size loss minus card error we are taking. Then we have what optimizer. We are taking Adam great. And then we have a x and y random value creating or step in range 30 and optimizer dot zero grade spread model loss of n spread loss dot backward optimizer step. What we have learned how LSTM works. What is BPT, what are weights, training code flow, how training code flow works. What is GRU? GRU means gated recurrent unit. It is a smaller and simpler version of LSTM. If LSTM is a robot with 3 doors, GRU is a robot with only 2 doors. Still smart but simpler. Why do we need GRU? Arnon is a weak memory, LSTM is strong but heavy. GRU is strong but light. So GRU learns long sentences but uses less power than LSTM. Means it's a faster training. And GRU has only 2 gates, update gate, reset gate. Let's understand them simply. Update gate means should I update my memory? You have a homework note. Do you rewrite them or keep the old ones? Should I update my memory? So like you have a homework note. So do you rewrite them or keep the old one? Update gate decides keep old memory or update with new memory. Keep old memory or update with new memory. If update get 1 fully update. If update get 0 keep old. Reset get should I reset old memory? So you start a new chapter in school. uh, so do you clear old info from your mind? Reset get controls. If reset get 0 forget old. If reset get 1 keep old. uh, how Jerry works. For every new word reset gets checks old memory. New memory is created. Update get mixes old plus new memory. Panel out is produced. That's it. No cell state like Lstm. Only one memory box hidden state H. Page is faster. Let's get paper calculation. One memory instead of two. Works well on small datasets where there is used chatbots, text prediction, time series, speech, task, small AI models, and we have a code and .gru input side and number talk dot and then 5 and gru and then .gru creates a gru layer input side each word 10 numbers each word can be hidden state memory size num layer 1 gru layer and then talk dot random 5 sequence words batch size 1 sentence feature size output gru x output for each word final memory hidden state Lstm has 3 get GRU has 2 gets Lstm slow GRU faster Lstm has 2 memory H plus C and 1 memory which is H only. Chapter summary. What is GRU? Why GRU is net update get reset get GRU memory flow simple python code GRU versus Lstm. End of GRU full chapter.